All right, well, let's go ahead and get started. Welcome everyone to this Tuesday afternoon webinar here at Digital Dimensions. We're going to be doing designing error-free assemblies today. I'm Jared Spaniel. I'm one of the product managers out of our Fresno office. I'm really excited to bring you this third part of this 20-minute learning series, and also let you know there is going to be 3 more parts coming up within the next few months here. We've gotten great feedback from some of these, so we're just going to keep going with some more topics that we've gotten some feedback on. And also, I will be recording this and sending it out in the follow-up emails, just as I have done in the past. If any of you guys want to rewatch it for some of the information or share it, or if you miss it or have to duck out, it'll be in the follow-up emails. All right, let's get started and jump into this. So I'm going to do something a little bit different this time. I'm going to change up the structure just slightly, just basically because there was so much information when I was looking into this topic and researching it and looking back at some of the common questions that I've gotten in the past and different things that I wanted to address. So I've broken it down into a few sections based on that. The first one is going to be, we're going to look at some mating best practices and tips. And then some large assemblies, so viewing large assembly tips, and then assembly best practices and shortcuts, and then of course the why SolidWorks assemblies, the benefits of why you should use the assemblies function in SolidWorks. So the first thing I want to start out with was just a quick knowledge test on mates. So I'm going to have a couple questions just to keep it interesting, get some audience interaction, and hopefully you guys, learn something, and then we'll go over the questions and, why the answer is the answer that I determined. So the first question, this is regarding mates. So if you're given a large assembly with many mates, I'm going to go ahead and launch the poll as well so you guys can start answering. Given a large assembly with many mates and an overdefined mate error, what best course of action would you take to repair it? And the choices are: chase every mate until the error clears, use the overdefined toolbar to help identify the problem mate, delete all the mates and start over, or put it back on the server and let someone else deal with it. So this is kind of a tricky question, as there are or could be multiple answers, but keep in mind that this is the best, easiest course of action answer is what I'm looking for here. So go ahead and take a second. Please answer that, and we will go over the question after this, and I'll show you why and what the answer is. So I'll give a few more seconds on that question if you haven't jumped in there and voted. All right, it looks like mostly everyone voted, so I'm going to go ahead and close this out. And it looks like mostly everyone, there was a few people that said A, and mostly everyone said B, which is actually the correct answer. Use the overdefined toolbar to help identify the problem mate. Now A, yes, you could do that, but it would be, very time consuming, a lot of extra work on your part. The other answer that's actually a potential answer, but not the best answer, is delete all mates and start over, which I wouldn't recommend, but in some cases that is actually a tip that SolidWorks gives on their actual help website that I saw. If you get into a really hairy, sticky situation, that may be required, but you don't want to go there unless you absolutely have to. So let's take a look at what I'm talking about here. If you guys don't know what I'm talking about, I have this bicycle hub that's already all set up in here, and you can see the tree here. I have a couple warnings and a few red errors letting me know that there's some issue with my mates. So of course, I could come over here and look at my mates and figure out, which ones are red and which ones are yellow, and then determine where the problem is and then troubleshoot from there. But, if you have this is a relatively simple example, but if you have a assembly that's hundreds or even thousands of components with hundreds and thousands of mates, I'm not going to want to sit here and look through every one of these and figure out what happened, what went wrong, why is this airing out. So let me show you the cool, simple way to do this. If you know, you'll see this overdefined warning down here. If you actually click on this down here in this toolbar, it'll pop up this window that just gives me a summary box of my mate errors only. So obviously what I want to do here, start from the red, of course. So these are all warnings, and then I have this error. So if I actually click on this, it'll tell me what's going on here, and it'll actually highlight the faces. It'll give me this nice pointer with a couple options in here to force it, mate, edit the mate, or suppress it. And it's actually letting me know that this is a perpendicular mate, and you can clearly see I have two faces here that shouldn't be perpendicular. They should be parallel, right? So all I have to do is right click on this, say delete, yes, and then X out of that. And that clears out that one. Now you can see, why is this still overdefined? Yeah, so there's something else going on here. So if I go back in here, in this case, what I actually wanted to show as another example was, yes, that was an incorrect mate, but the second thing I have going on here is this actually has too many mates. So I've got too many mates here for this. So if you look at, you can easily troubleshoot based on the amount of mates you have. I have a lock mate here, so I'm locking these two into position, and I have a distance mate. So it's actually still telling me that it's overdefined. So if I delete one of these, or both, so I'll delete that one, and it's still telling me, yes, it's overdefined because I still have this distance mate. So I'm going to go ahead and delete that, say yes, and now you'll notice that it's actually cleared out here. So I have all my mates cleared out. So in this case, there was actually two issues. There was an overdefined mate, and there was a I had too many mates, and I had an incorrect mate. So let's jump back into the PowerPoint. So that's one way to solve that mate error really easily there. So the next thing I want to show was this little mate scheme that I researched a bit. So a really good tip is, when possible, mate all your components to one or two common fixed components or references. So you can see the good mate scheme on the left. Every individual part is based off of mating to one part, and then on the right you have basically what they call a chain of mates. So you have one part mated to the main part, and then other parts following along that. You want to avoid that, basically because the longer the mate chain, the longer your solve time is going to be. So whenever you rebuild your assemblies, it's going to take a lot longer to rebuild those assemblies, having to solve all those individual mates that are chained together, or also avoid circular mates. So same principle, circular mates and chain mates. So follow that good mate scheme there on the left, and you should be okay. And if you guys have that set up as a best practices and everyone uses it, you'll definitely help out when opening those large assemblies and rebuilding those large assemblies, which we're going to talk about kind of in the next section here. So with that being said, there is also a hierarchy of mating on what you should mate to what. So did you guys know about this? This was kind of interesting. I usually follow this practice, but if think about what the best things to mate are, planes. So everything is start with planes before faces. Every assembly has default planes. Utilize those planes. And then if that's not giving you what you want, go ahead and use the faces. Then the next one's going to be faces before edges. And then the last one finally is going to be edges before vertices. So keep that hierarchy in mind whenever you're mating things, and that'll definitely help out with your rebuilds as well. So, do you follow the hierarchy? Keep that in mind. Remember, when you're mating things together, try to follow that hierarchy. All right, let's look at some of the best practices here. So this is going to be just kind of a big list I wanted to go over because I found a lot of information. These are kind of the ones I pulled out that I thought were really the most important. Drag components to test their degrees of freedom, kind of an obvious one if you're mating things together and you have a component, you want to know if it's actually mated, just grab it, grab a face and try to drag it, and SOLIDWORKS will tell you, yes, this is fully mated, or it'll let you move it. Fix mate errors as soon as they occur. So of course, kind of obvious, adding more mates isn't going to help you with the problem. As soon as you see a red or yellow error in your tree, try to go back and troubleshoot that like we just looked at and figure out what's wrong. Don't continue adding mates. This is a good one. Place components in their approximate final location before mating will give you a better chance of solving it correctly when you go to mate it. So if you have something on the other side of a large assembly flipped upside down and you're trying to make two faces coincident, when you mate those together, you may or may not get it in the place you want it to get. Whereas if you put it in the position kind of in the general location and then mate it, it'll probably go where you want it to go. Create mates in sub-assemblies opposed to top level. I'm going to harp on this one a few times because this is really important. So I know people out there are probably saying, well, maybe I don't have these sub-assemblies, or how do I create these sub-assemblies in a large assembly? But always try to break your components down into smaller sections, smaller sub-assemblies, and then mate those into a larger top level to reduce the amount of mates in the top level. And that'll save your opening and save your rebuild time, which we're going to talk about a little bit more as well. I've had a lot of questions on that. And then when possible, fully define the position of each part unless you're going to actually need it to move to visualize motion or do some kind of simulation or check clearances or something like that. If you constrain all your degrees of freedom, that will definitely help when rebuilding. So the next kind of question I have to start off the next session is going to be on assemblies. I'm going to go ahead and release this poll right now, and please take a moment and answer that question. What is the best way to increase performance when dealing with large assemblies? I've had a lot of questions on this, a couple emails on, I'm having trouble with my assemblies. It's taking forever to load. It's taking forever for me to open things. How do I essentially optimize this, right? So the choices are use sub-assemblies, use configurations, fully constrain all your components, utilize large assembly mode, or all of the above. A few of these we already talked about, so go ahead, take a second, answer that. Give another few seconds and wait for everyone to get their answers in. And just think about that question, think about what we already talked about. And if you guys don't know what these are, we'll definitely be going over some more options and things here. So let me give just another second or two here, and then I'm going to close this out. All right, looks like a few people are still getting their last minute votes in. All right, I'm going to close this out for time's sake. So the correct answer, all of the above, right? So everyone was pretty much right, no matter what you selected. But all these answers are correct. All these answers are great ways to increase performance. With that being said, let's take a look at the first one here, where you would start optimizing your software setup. So this is going to be the lightweight mode and large assembly mode. So what lightweight mode is this is an option that you can set up in the system options, and I'm going to show this in just a second. But this is this will open the assembly and all of the parts into your RAM, but not load the parts feature data. So it's going to open the assembly faster, but still load all the graphic data. So when you need the part features, simply just right click and then set the part to resolve or edit the part, and that step will load the individual parts into your RAM. And then the large assembly mode is another useful mode if you have so many components, and you can set the amount of components that you want, but it's very useful to turn off the edges and shaded mode option as well. So that turns off all the little black edges on the parts, which is a huge savings on your graphics cards if you have a lot of parts. So let's take a look at this actually in SOLIDWORKS. So if we open up it's under performance here is where you would normally start, and you can customize this however you like. I have mine set up for the things I do, but you can turn off these two check marks for high quality, and then of course you can turn this down to less for the level of detail. That'll make it faster. But the main one here that we were talking about was automatically load components lightweight. You can just check that, and that'll definitely speed things up. And then we talked about assemblies. So if you flip over to the assemblies tab and check the use large assemblies to improve performance, and then you can customize the amount of components that you see here. The default's 500, so if you're working in assemblies that are smaller than that and you want to default it into large assembly mode, just bump it down. Another good one is having these two on, so hide all planes, axes, sketches, curves, annotations, and do not display edges in shaded mode. I would recommend against having the do not rebuild and do not save auto recover checked for obvious reasons. Do not save auto recover info. Yeah, you definitely, I'd probably not have that, keep that unchecked. Another good one that I'm just going to touch on is this use large designer view whenever working with an assembly. So if you have a really, really large assembly, this is kind of more for best used for kind of presentations and reviews. So you can see the default's 5,000 components. You can bump that down if you want it to default into a large design review mode. But this is a good one to show some stuff. The things you can do with it are limited, but it's great for showing and demonstrating or presenting with. So that's another option there if you want to use that one. Let's close out of that. So a couple other things for the assembly best practices and shortcuts, and then I'll kind of show a few of these off. We talked about this. I'm going to harp on this one again just to reiterate. Avoid large assemblies. Use sub-assemblies as much as possible. Configurations. Use configurations. Those are really great. So if instead of having a whole bunch of the same part put into an assembly, you can just put one part in and then utilize the configurations to switch maybe different sizes if you want to vary a dimension. Different options and things like that. That's great. Fully constrain, we talked about this. Fully constrain all your components if possible, so utilize all your degrees of freedom. That'll help with the rebuild time and trying to figure out what's going on in SOLIDWORKS when you rebuild, if things got moved. Mate your initial components to the default planes. This is a good one. This is a personal just kind of preference of mine. And it also makes for good design practices whenever you're building an assembly off of an individual component. Mating your individual components to the actual assembly planes themselves, and I'm going to show a few cool little options with this. And then if you guys didn't know, the tab key will flip components 90 degrees and also hide your components. And if you want to unhide things, you can do shift and tab to show. And then the alt key is another good shortcut for using smart mates. So let's go ahead and jump into there and show some of that. We're getting a little low on time, but I definitely want to show a few of these things. The first one was the bringing in the actual parts. So when I do insert component, I had this question recently. If I select the component, so this is just a blank new assembly. If I select this component, right, and then if I just drop it into space out here, what happens is the part, yes, it's got an F here, which indicates it's fixed. I can't actually move it. You can see it tells me it's fixed. It cannot be moved. But what's going on is my planes are actually not lined up. So you can see my front plane is off, my top plane is off, and of course, the right plane is off. So my part is fixed. It's in the assembly. It's not going to move, but it's actually not mated to the original assembly planes, which is what I wanted to do. So I could come in here and, unfix it and then manually mate all those, but, don't waste time doing that. So what instead we can do, bring this, instead of just dropping it in space, just use the check mark. So highlight what you want, grab the check mark, and now you can see still fixed. It's in space, but look at the difference. Front plane is now mated to front plane. Top plane is mated to top plane. Right plane mated to right plane. So all my planes are mated. So just be aware of the difference. You can do it either way, but if you just drag and drop and throw it in there, it's going to be somewhere off in space. If you do the check mark, then the planes will mate themselves appropriately, and that's what I prefer to do whenever I bring a part into a blank assembly and start building off of that. It's just good practice for mirroring, mating, other things. Everything's lined up, right? So I'm going to close that out. So the other one I wanted to show was bringing in a component to something like this. So if I do insert component, if I bring this in here, I'm going to flip this. The tab key will actually rotate my component. So if you're bringing in something like this and you don't want to mess with it, you don't want to drop it and then mate it, just use the tab key and that'll rotate it into the position you want. So in this case, of course, I want it to be in this position. So I'll drop it there. And then I'll use the control key, hold that, and then I get the flyout manager for the mates. So let's mate that up. And then the other one I wanted to show, you can see it's not fully constrained here, was the Alt key. So if I grab the Alt key and hold this, when I drag this in, I'll get this the two little boxes letting me know that I'm establishing a kind of a quick mate there. So I want to mate that edge to that face. Say yes, and then of course it's actually mated in place there. So I'm not going to go into too much more detail on defining this whole assembly or anything. I just wanted to show those quick shortcuts. Oh, and the hide. So if I do tab, so I can tab and hide over anything. So I'm just touching the tab key, and then if I do shift tab, it'll bring back my components, so you can see the other components that I actually had hidden in the assembly now appear. And then if I hold tab, I can just basically mouse hover over all those components and hide them. So that's a great, if you want to see something really quick, you can see I'm just hiding all the components by holding the tab key and hovering over everything, and then shift tab, bringing everything back. Cool. So kind of a summary on the tips and the best practices. Just remember to mate to one common component. Try not to chain your mates together or have circular mate references. That causes issues when rebuilding and slows things down. Mate with planes whenever possible. Try to use those planes instead of, remember the hierarchy, planes, bases, edges, vertices. Fix mate errors as they occur. So if you get a mate error, just go in, figure out what you did, fix it. Don't pass it on to the network and let someone else open it up and see all those red errors and cautions. That's not fun. Create sub-assemblies. So I've mentioned this one multiple times. I'm going to say it again. Create sub-assemblies to reduce the number of mates in the top level. If you have very, very large assemblies, reduces the opening time. Fully constrain all components as well, reduces opening time. And don't forget about customizing those system options first. So if you're in there and you know you're going to be dealing with assemblies of certain numbers, go ahead and go in there, turn those checkboxes on under the system options for performance and assemblies, and get all that set up to best suit your needs. Another one, don't overmate components. I showed this one kind of in the little demo at the beginning with the bike hub about having the components together. And even though I solved the warning mate, or the warning mate with the red error, it still was giving me some errors, letting me know that I actually had a couple components overmated. So I can just delete those out and then it'll clear out the tree. So some quick benefits of what we looked at today for assemblies. Assemblies are great to verify components fit or moving with clearance. Great user-friendly intuitive mating commands. So just remember holding the control key and selecting the two surfaces, planes, or whatever faces will bring that mating flyout manager up for you, so you don't have to actually go into the property manager. And then easily create and show large assemblies. We looked at a bunch of options for doing that with the system options and other great tools to help speed up some of those large assembly problems. And of course, the big one that we always harp on, all these things kind of go down to cost and time savings. So some upcoming content I just want to throw out there. If you guys are enjoying my webinars, feel free to join me. I have another one Thursday. We're going to be doing Communicate with CAD, which will be looking at Composer. So if you have an interest in Composer and you want to see some stuff, please feel free come and join us for that one. It's going to be Thursday at 2 p.m. And then, of course, look out for our next 3-part installment of this 20-minute learning series next month, July 19th too. We're going to be working with other CAD files and SOLIDWORKS. So I've had quite a few questions on things of what files we can import, export, what files we can look at in different softwares and how that all works and what the functionality is. So I'll be looking at some options and different things dealing with that topic. So I just want to thank you guys for attending. Think about anything you saw today that could benefit you. Think about how SOLIDWORKS can help for upcoming projects. And of course, don't forget to follow us on our social media accounts. If you have any comments, questions, concerns, just want to say hi, feel free to email me, jspaniel@ddicad.com. I've gotten a lot of good feedback on these webinars. Love hearing good feedback. If there's something that you want to see, let me know. If there's something you don't like, feel free to let me know too. I'll definitely take a look at it and always looking to try and improve. So thanks everybody for attending. Have a great rest of your Tuesday, and remember the recording will be in the follow-up email. All right, have a good one. And I'm going to hang out for a bit more if anyone has any questions right now they want to throw out there, and I'll try and get those answered.